Hey folks, welcome back to the Raspberry Pi build segment. I had a good long think about how to do this in stages and to stage it out so that it's easy to follow. In the last episode, we walked through creating the micro SD card, inserting it, getting the Pi loaded, up and running, and updated. I've done nothing else to the Pi since then. So today, one of our tasks is going to be getting the Raspberry Pi to working on the 7-inch touchscreen display. Again, we're just going to build this in sections so that we can kind of build, your base knowledge, that fundamental of the steps to proceed. And then you can expand as you go on, or we can take it in a different direction if you guys feel you would rather learn something else. When you first get the 7-inch display, it comes with the display, the driver and power board. It comes with your GPIO cables. These are actually your serial connections to establish where on the screen you're touching. It comes with a 4-inch ribbon cable to connect from the display up to the Raspberry Pi. So that ribbon cable goes in the end and will loop down and plug into this one right here. You get 4 screws, which allow you to mount the Raspberry Pi to the standoff posts. Sometimes, now the first time I bought one of these displays, the controller board was not mounted to the back of the display, nor were the cables hooked up, the ribbons. It's very straightforward. There's a wider cable that goes to the underside of this board, and the narrow cable goes up here to J4. It's very straightforward. If yours did not come with instructions, you can just go back to the website and look it up. It's fairly straightforward to find all of the information we need. Okay, so as we move on here to, sorry, I keep getting interrupted here. The ribbon cable itself, if you take a look, it has 2 shiny connector sides and a piece of tape on the opposite side to prevent a short circuit. What we're going to do, it doesn't matter which end of the cable you use, but you're going to remove these, not remove, you're going to pull out these little tabs here, and you're going to insert the cable very gently all the way in, and then proceed to lock it in place. There we go. This one is much tighter connection than the previous one. What I like to do is just give it a gentle tug and just make sure that it doesn't come out. You can see I'm not putting much force on it at all. I'm just making sure that it is properly seated. Most of the connectors that they're using now, you actually go over this bar, this black bar piece, and I realize it is very difficult to see, but the main body of the connector is brown, and there are black tabs on either side. These are the lock pins, the pressure connector. If you think about it, it's kind of a wedge shape, so it allows you to insert the cable, and then when you push the connector back, it puts a wedge on it to lock it in place. It's a very simple connection, but it's rock solid once. Okay, I'm assuming you've now gotten this all together, or yours came assembled. The next thing we're going to do is grab our ribbon cable. It doesn't matter which end you use. Some of them have a natural curve to them from the way they were packed. If that's the case, just stick with that curve and find the shiny side. You want the shiny metallic connectors sticking up as you go into the port. We're going to pull our clamp out. If you notice, the body of the connector is brown, the clamp is black. So you're going to pull these 2 little tabs till they slide out. It's probably a 1/16 of an inch out, and that is unlocked. It will not come out any farther. If it does, you broke it. Again, we're going to go shiny side up. We are going over the top of that black bar. We're going to slide the connector in. Just get it in there, seated firm, and then you're going to lock the black pins back into place. Now the two tabs are locked back in against the body. You can just give it a light tug. You don't want to go ripping on it. Just give it a light tug. Make sure it's seated. And there you go. Now we have our display cable hooked up. Okay, for the next part of this, while we have our pins exposed, now is the easiest time to put these wires on. If you do them once you've mounted the Pi, it's very difficult to look in there to see which pin is which. You're referring back to the schematic, so it makes it a little bit more problematic. So basically what we have is we have a 5-volt input is our first pin. We have an interrupt. We have a data port, which is marked as SDA. SCL is the clock port. And then we have a ground. So to kind of stick with a typical convention, what I like to do is I just come in and I take my red to the 5-volt positive, my black to the 5-volt ground, my yellow goes to the interrupt, is that right? No, that is not right. Yellow is for the system clock. Sorry, I totally screwed myself up there. And then the green we bring to the data input. We are skipping interrupt on our build. The interrupt pin could potentially be used if you are programming and you're writing directly to the screen, or if you need to do, we'll say you want to run Windows 10 IoT on this display, you will need the interrupt pin connected. So you could just do that with whatever color you want. Typically interrupts are purple in this environment, so if you have an extra set of these jumper cables that may have came with your breadboard or another Raspberry Pi or another GPIO device, and I say that and I'm looking to see if I have a female to female purple. I do not. I have a female to male purple. I'm not going to use it, so for my purpose I will skip this. If you plan down the road, you can add that pin now, that wire, if you have it. If not, don't worry about it. We can come back to it. And just one more time for clarity. Red is to 5-volt. Interrupt is left blank. Data is green. Our system clock, the SCL connector, is yellow. And black for ground. One more time. Red to 5-volt. Interrupt is blank. If you have it, it's preferred that you use purple. SDA, so our data connection, is green. SCL, our clock connection, is yellow. Our ground connection is black. Okay, now continuing on, we now have our ribbon cable hooked up. We have our GPIO headers. In there, our next part of the project is to simply mount our Raspberry Pi board using the 4 included screws that came with the LCD. I would recommend that you use a 00 precision Phillips. You don't really want to strip out the heads of these little bitty screws. This is where it helps to have an extra set of hands. I will be the first one to admit to, as part of getting older, I am slowly losing dexterity for the fine screws. Talked to a lot of guys in the electronics industry and a lot of guys working on computers. All of us that are older have the exact same complaint, that we are slowly losing dexterity, and particularly for fiddly things like this. It helps if you have a magnetic bit. I am somewhat adverse to magnetic bits on small components. I just noticed something I did not point out. I did it by habit. I will show you in 1 second. Let me get this last screw down in here. So it's automatic for me to ensure where my headers wind up. If you'll notice, our GPIO cables are on the top coming out, so immediately it lined up to the GPIO pins on the board. Same thing with our display cable. This is our display port on the Raspberry Pi. And we have our two 5-volt DC inputs. The way we're building this, you will not need the 5-volt display power input. We are going to take power from the Raspberry Pi via our 5-volt DC and our ground that we hooked up to there. Okay, and now that we've got that part done, I'm pausing to think through the steps so that I don't miss anything. So now that we're hooked up, the Raspberry Pi is fixed mounted to our panel. Our next function, I want to note though here that your micro SD card will be hidden under this cable once we make it. I would recommend that you get a fine set of angled tweezers. I showed you guys those in a previous video. It does make it much easier to get in there and get the cable otherwise, or get the micro SD out. Otherwise, you need to remove this ribbon cable. So very quickly, all we're going to do is similar to the bottom one. We're going to pull these black pins up, or this black bar up. It comes seated. There's a little tab on each side. Just pull that up. Make sure it's all the way up. You can see here that our display header actually comes out and makes contact with the board. You can see all of the pins sticking up as they come out to the board. So what you need to do is make sure that you have your shiny side of the cable facing that way. If you inserted it wrong, you're going to be looking at the blue edge facing towards the middle of the board. So just there's one more chance for you to check it to make sure that you're pinned down. And that's it. Basically, you're going to flip it around. Again, place it in there. Slide it down. It's a very easy fit. It will stop when it's in all the way. You're going to come back in and seat your black tabs. So now I can pick this up and show it to you a little bit. You can see that we are fully inserted. Again, the same thing, a light tug test. Don't wrench on it. Just give it a slight tug. As long as it stays seated, then you know that the clamps are properly in place. Okay, I paused to try and get this into a little better focus here and get you a little bit closer in so you can see what we're doing. So now we're going to hook up our GPIO. In this case, initially, right off the bat, we're going to start with power. The red power, which is your 5-volt, we know is automatically this bottom right corner pin. So if the board is oriented to you the same way it is to me, so that you can see the HDMI logo is facing away from me. So the top right pin, in this case the bottom right for me, sorry, top left for you, bottom right for me, is the 5-volt positive. Our ground, we're going to come over 3 pins. So if I can get this lined up in my hand, we have 1, 2, 3. There we go. So we now have our 5-volt positive and our ground hooked up to the board. Cover them up here so you can see them. Again, the red one is in the bottom right pin. And then 3 pins over, 1, 2, 3, is our black. At this point, you could stop because you have successfully brought power from, you're bringing successfully power from the Raspberry Pi down to the display board underneath. I will continue here and walk you guys through getting our data. Oops, you can't see those. Our data and our clock brought up. Okay, so the next two that we're going to hook up are clock and data, which is actually pretty straightforward. We're going to loop over, and I'm sorry, I'm pausing to look at a wiring diagram to make sure I get to the right pin. Another thing that may make it easier in the future too, if you notice, these have a crimp port, but it's also good for testing if you have to come back through with a multimeter and actually take a measurement off of that port. You can see the little silver port right there. And I typically will turn those opposites so that I can get to it from either side of this pin array. So yep, we're coming. Now I'm having to actually look at the camera to make sure that I am getting the correct pin. Yes, we are on the correct pin. It would probably help if I took off my reading glasses and put on a pair of cheaters so that I can actually see what I'm doing. So that's our data, and the next one over, yep, is our clock, and we're going to skip. I mean, we're not going to skip, we're going to go right next to it on that next pin. And that's it. We are connected. There's all of our connectors all bundled together. I'm looking for a wire tie. Usually I have them laying around. I'm a little bit old school, and I like to come back and lace them just to make them a solid bundle. I will let you decide whether you want to lace them or not. It just gives the group the bunch of cables, if you want to put it that way. I guess I could zoom back out here a little bit so you can kind of see what I'm doing. I'm not doing a fancy lace by any method or by any means. I did learn how to lace when I was younger, but I don't necessarily need to lace these. I am just trying to give this bundle a little extra structure to it. If you have a pinned out ribbon cable, you could actually use that as well. I'm just making use of some cable ties or wire ties that I have laying around. Same thing, I'm just going to come in, give it a bite, fold my end under, and then wrap the cable around. That's all we're doing. Nothing fancy. It's just to give it a little more structure, a little more rigidity, to hopefully fend off the cables from vibrating loose. So that's all I've done. You could get fancy and hot melt glue these in place. Just be careful of the temperatures that you get it to, but I have done several builds with Raspberry Pis, including a radio build, software-defined radio build, where I used an actual 40-pin jumper to go to a daughter board that was a breakout board. And I actually came through and hot melt glued it in place so that it wouldn't go anywhere. And that's it. Again, you do not need the yellow and green if you have no intention of writing code to specifically manipulate the screen. If all you're doing is power, then you only need the 5-volt DC, which is our red, and the ground, which is our black. And same thing, they go to the, as the GPIO headers are facing you, pin 1 in the bottom right corner is 5-volt DC. Pin 4 on the bottom row, so counting over 1, 2, 3, 4 pins is the ground pin. Your video, your display is transferred via this ribbon cable. And that's all you need. Okay, so now I'm changing glasses back. We are at a point where we are ready to power up. So this is where your board selection is going to make a difference, whether you use the A+ or the B+ with more connectors. I'm using the A+, so I only have one USB connector on the Raspberry Pi. Not that big of an issue because I have a unified Logitech keyboard that has a keyboard and a touchpad built into one connection through the unifying receiver. So we are going to plug that in. This is my keyboard and mouse. Wi-Fi, we established that all worked previously. In this configuration, the HDMI port will not work, so we're eliminating the HDMI. Our power connection no longer connects to the Raspberry Pi. It will actually connect to the micro USB down here at the bottom. Oops, I'm going the wrong way. On the display board, not the one on the Raspberry Pi. So you could put a little black X on there if you wanted to. I'm going to remove this piece of static board just out of the way. Actually, I think I'm going to do this the other way around so that you can see me make that actual power connection down on the driver board on the display. So you know how you get ham-fisted when you try to be too delicate. So just to back off here a little bit, I'm going to try actually, hi. Yeah, I think that'll work all right. Trying not to put too much stress on different cables. I need a box. I need something to hold this up. Okay. Let me back you guys off a little bit so you can kind of see a little bit more of what's going on. This is oriented towards me. Your view is upside down now when it powers up. All right, we are going to go ahead and plug in. You will notice the screen initially flashes white. If you didn't watch the previous video, that's not a scratch in the screen, it's in the protector. I notice people love to point stuff out like that. So anyways, so we are ready for the first power up. The screen should turn white and then you will see the rainbow logo. Here we go. So now our screen is booting. The Raspberry Pi, you can see, is actually booting up just fine. We're going to let it complete the boot. Now, I don't know if this is showing up, and it actually detected it right off the bat. Initially up here there was a yellow lightning bolt. The yellow lightning bolt indicates that we did not have enough power to run the system. However, it did complete its boot. Let me bring up my controls for the webcam again. See if I can adjust some of this exposure a little bit so you can actually see the screen a little bit better. Here we go. And our focus is off a little. There we go. I will try and spin this around in the video for you guys to see. If not, I apologize. But yeah, so we are booted up. The time is not correct. We will give that a minute to catch up. Our audio is, I don't know why our audio is actually working. We have no audio out right now, but there's our Wi-Fi connection. Our Bluetooth is enabled and our serial ports. You can see that it is tracking my finger. I will grab the trash icon and move it around. So there you go. Right off the bat, we are working with all of the simple stuff. Anyways. And something just dawned on me as I stopped recording there. our time is correct, so that's good. We were able to actually go out and get our current time. One thing we do need to do, now that we've installed this board, we did an update of the Raspberry Pi prior to this. However, we've added a new device with this display. So one more time, we're going to run sudo apt update. And just make sure that we are updated, which we should be. Oh, maybe not. It is actually downloading. So what I'm going to do here is try and come down and maximize this screen. Oh, I did get a question on Fernweh. Obviously somebody doesn't watch the channel normally. Fernweh is German for Wanderlust. That is the name of my van. So there are 2 updates available. We're going to go ahead and apply them with sudo apt upgrade. Some people say sudo. I've gotten so used to saying sudo over the years. So there you go. We're downloading 2 packages. It needs to get 370K. After that, 551K will be taken. So there you go. We will run these updates. And then we will pause and I will look at a couple different on-screen keyboards and figure out which is going to work better for our purpose or my purpose in general. Okay, so our updates are done. There you go. And again, we have the lightning bolt, which means we're just a little shy on power. Yeah, everything appears to be working right. One quick indication for, like, if your network connection is not right or something, other than, I'm looking for my little chopstick, other than your indicator for your Wi-Fi connection. Another good one is the clock, because these default to NTP or Network Time Protocol. So if you happen to reboot and your clock is suddenly an hour off or 30 minutes off, it gives you a good idea that you need to look at your Wi-Fi connection and just make sure that you're connected. Okay, moving on. We're going to add our keyboard, which in this case is sudo apt install match. It's matchbox, I believe, dash keyboard. Just make sure that we are correct. Okay, matchbox dash keyboard. Oh, I spelled it wrong. You know, if you didn't know it, I'm not perfect, okay? I make mistakes. We all do. We all make mistakes, we all have errors, and that's what makes us human and unique. Yeah, you can see how small that keyboard utility is. It's very small. But in reality, there's not much to changing out an on-screen keyboard. But if you look at your mobile device and install a different keyboard, it is multi-megabytes of data. And in this case, let me leave that open here. All right, let me stop and read the manual. I need to RTFM. So I was right. So the startup command is matchbox-keyboard. We can integrate that later so that it automatically starts up. Okay, good. Now we have the keyboard on the screen. Oh, well, that's okay in this case. So now you can see the keyboard is up. So we will do... Okay, I'm reading this upside down and trying to get my dexterity right. Did we put in a C? Yeah, good. Well, it doesn't matter. As long as we're putting in text, we know that it works. Home. And, okay, they are all mapped correct. And there you go. There's our on-screen keyboard. You should be able to just grab it. Yeah, you can. Grab it and drag it around. Oh, what a pain in the rump. So I'm trying to minimize this terminal. This is what I was saying about why it's good to have a backup keyboard available while you're setting things up. And that's it. You now have an on-screen keyboard. Again, this is basics just for data entry is where this exceeds. So we'll just quickly... This is really weird when you're looking at the keyboard upside down. Backspace. I'm just going to do an LS and then hit return. So we're showing you what's in your current folder. That's just a listing of the files in that folder. Okay, so we know that we are working. We know our keyboard is working. Let's make sure we shut down here, and we did. Okay, good, we exited correctly. And that's it. We now have a functional Raspberry Pi with touchscreen. Again, I would recommend some form, whether you want to use, a small keyboard like this one, which I forgot to have the display dialed down, so it's going to be dark, or a standard full-size keyboard. How you go about it from there is up to you. All right, guys, let me put this video together. We will get this one out, and then tomorrow, or I should say in the next video, we will take down something else. For people that are tracking video, today is Wednesday, April 29th, so I did do this and post it the same day. I told you guys I wouldn't do any tricks on you, so just to show you. All right, so we're going to go ahead and do a shutdown. And that's it. All right, guys, that's it. Be good, be well.